Does insulin resistance increase my risk of heart disease?
Yes. It's possible to pick up an increased risk of certain cancers as well. The major thing which makes us more insulin resistant is putting on weight and eating simple, highly processed foods. However, there is a lot that you can do to improve it by the way you eat and the way you lead your life. And the roots of a lot of insulin resistance lie in our...
It's really fascinating. So it is possible to reverse your insulin resistance?
Yes.
Rob Semple is a professor of translational molecular medicine at the University of Edinburgh and a board-certified doctor who specializes in metabolic health and rare metabolic disorders. He's published over 100 papers and is a world-leading expert on insulin resistance.
Insulin is, I would argue, the most important hormone. However, it makes you feel unwell fastest if it goes wrong. If you have a normal sugar level, but you require a very high insulin level to maintain that, that is pure insulin resistance. And on average, around a quarter of the population have insulin resistance. At very high levels of insulin, it comes with unexpected additional health risks.
Does insulin resistance only affect people with excess body fat?
No. Some people can move into the very obese range and really have not much in the way of insulin resistance. Whereas some people in the normal weight range, they can begin to get those complications. And risks for a young generation now are higher than they were for older generations because in general, we live less healthy lifestyles as well.
If someone's been listening to this podcast, worrying about their insulin resistance, if you could only give them one piece of advice, what would you tell them? Rob, will I live if my body stops making insulin?
No.
Has there been a huge rise in the number of people with insulin resistance?
Yes.
When insulin is working well, can it reduce blood sugar spikes?
Yes.
If you develop insulin resistance, is there anything you can do to reverse it?
Yes.
Can someone have insulin resistance even if their blood sugar level looks normal?
Yes.
If you develop insulin resistance, is diabetes inevitable?
No.
What's one thing that most people get wrong about insulin resistance?
Insulin is a rapidly changing, complex hormone that can go wrong in many different ways. And trying to package it all into one thing called insulin resistance is often misleading.
Imagine a version of you in 6 months' time. Someone who's made a few small changes and feels dramatically better because of it. That is why we make this show, to give you the latest science and the tools to get there. But to keep doing that, we need your support. If you've gotten value from this episode, please hit subscribe. You'll get a front row seat to the latest science, and we'll keep doing all the work to bring it straight to you. Okay, now back to the show. Insulin resistance is a term I've heard quite often when people are talking about blood sugar control. But whenever I have it explained to me, I am quickly overwhelmed by the complexity, and honestly, I just give up. And I'm hoping you can explain this to me through this podcast in a way that I can understand what it means. And actually, before we talk about insulin resistance, could you just talk about what is insulin and what does it do?
Exactly. And this is where we have to start. So insulin is, I would argue, the most important hormone in the world. Certainly, there's no more important hormone. And a hormone is a chemical messenger, which comes from one bit of the body and sends signals to the rest of the body. So that's the start. Now, insulin solves an absolutely crucial problem that is essential to life. And the problem is that many of our key organs need energy and nutrients constantly. Our heart, brain, kidneys, etc. And yet, we don't eat constantly. We eat once every so often. Increasingly often, I acknowledge, but through much of human history, we've had long periods of fasting or even starvation, and then episodic binges of food. And so insulin solves the problem of smoothing out that energy supply to organs. So every time we eat, nutrients are taken up from the gut and insulin is made. And insulin completely remodels the body's metabolism. So when we fast, when we don't eat, we need to be trickling out energy from our energy stores, mostly in fat tissue, but also in the liver. But as soon as we eat, we need to recognize that we've eaten and then replenish those fat stores. So we reverse everything to store energy in the fat stores and also allow the tissues to grow in the times of plenty. And insulin is that thread which connects what we're doing with our diet and our body's metabolism. And we know it's absolutely essential because of the horrible consequences of not having any insulin at all. I think we're all familiar with type 1 diabetes when the body makes no insulin. Still an important problem, but it's transformationally different now to how it was just over 100 years ago before we had insulin to deliver. In those days, if you were diagnosed as having no insulin, as having type 1 diabetes, it was essentially a death sentence and led to wasting away and death, often of teenage children, over the course of 2 years. And I think it's very easy for us to be more blasé about insulin these days, but it was equivalent to being diagnosed with an advanced cancer. And with a starvation diet, you could buy a few extra months, but that was more or less all you could do. And then once insulin was identified and purified from the pancreas and injected around 1922, it was a transformational difference. All of a sudden, people went from looking like skeletons to looking like normal children over the course of a few months. Nobel Prizes quickly followed, standing ovations on the London Stock Exchange. And it was established that this was that missing elastic link between our diet and our metabolism. And it seemed at that moment in history as if diabetes had been solved.
And can you help me to understand a bit more how insulin achieves this? I think I've got this picture in my mind that I'm eating food episodically but I need to give like energy all the time to parts of my body. How is insulin doing that? And I guess also, how is that energy being delivered to these different parts of my body at a consistent rate, given that I'm only eating from time to time?
Yeah, so metabolism means cooperation between all the organs of the body, which have different roles. Some of them are storage organs, some of them are energy burning organs. Energy burning organs might be the brain and the heart, for example.
Quite important places then.
Well, indeed, we're all quite keen that they carry on functioning even when we're not eating. And let's take fat tissue, a very unglamorous tissue, but let's take it as the example of the key storage tissue. And the reason fat tissue is fat is because the fats in it are the most energy dense type of storage fuel. So when we eat, insulin triggers the uptake of sugars and also fats into fat tissue, and it's converted into this very dense fatty material for storage there. Fat cells in our fat tissue are more or less balloons full of fat with a tiny rim of apparatus around them. So when the times are good, when we eat, we steadily build up those cells, we fill them up with fat, and we make more cells if we have to. Then when insulin levels run low, and that's because we aren't eating, then gradually that shifts. And instead of taking up nutrients into the fat tissue, we start re-breaking down that fat again. And that fat gets turned into more easily metabolizable chemicals, and they get trickled to the liver, which works together with the fat tissue to package it and send fuel to the heart and the brain. And that happens to lesser extents across lots of the tissues of the body. So it's a matter of a sort of seesaw between storage and then energy release. Equally, muscle tissue and liver and kidneys are able to store some energy as complex carbohydrate as well. But that supply is very much smaller than fat tissue.
So I'm sort of thinking a little bit now, almost like a hybrid car, one which has got the electricity and it's also running on petrol. And so it sounds like you're saying like the insulin is almost sort of filling up my battery when I'm braking or all these things, and then it's able to say, oh, now I need the electricity, pull it down and start to have access to that at the time when I need it.
Yeah, I think that's a very nice analogy. So you refuel the battery in the good times, and then you draw on those stores in the battery in the bad times. There is a little bit more to it than that, and insulin actually is also very important for allowing many tissues to grow. So insulin acts to stimulate growth of a variety of different tissues in the body as well when the energy supplies are lowered. So it's not just about storage, it's also about growth.
You haven't really mentioned the word blood sugar yet, but the thing in my mind that it's very much associated with is that it's sort of blood sugar that is feeding these things and that it is adjusting that level in the blood. Could you help me to understand?
Now, so you're guiding me now into the first bit of complexity. So you are quite right. People think about insulin in terms of blood sugar, blood glucose, as we doctors think of it to be more precise. And that is widely regarded as the most important thing that insulin does. And that is because that's the thing which makes you feel unwell fastest if it goes wrong. So glucose is one of the chemicals which is taken from the diet when we eat it, and it's a very potent stimulator of insulin release. And when there's lots of glucose, insulin drives its storage and serves to take it back to where it should be. So yes, a key role of insulin is to keep blood glucose fixed. However, insulin does far more than just regulate blood glucose. It also regulates the metabolism of fats and the metabolism of proteins. And in many ways, those are just as important for long-term health. But they don't make you feel dreadfully unwell if they go wrong very acutely. So we have a reasonable fixation on blood sugar, but insulin does very much more than regulate blood sugar.
Could you help me to understand what my body is trying to do in terms of blood sugar and what the insulin and my meals, how does that play in, like if everything is going well? Because I think we're then going to start to talk about what happens if it isn't all working perfectly, which you told me has now become sadly very common.
So of all those different fuels, sugar, glucose, is the simplest one to burn in tissues. So it is the main currency of our metabolism. And in particular, it's important for the brain, so that if sugar levels drop too low, the brain starts to malfunction. And if sugar level drops very low, then actually confusion, unconsciousness, and seizures can result. So it's crucially important to maintain that glucose and prevent it from dropping low. It's also harmful if it, in the longer term, if it goes high, as I'm sure we'll discuss later during the podcast. But it's such a crucial safety concern that the body has had to develop a key mechanism to regulate that and safeguard it and hold it at one level. And that's why it's got what we call negative feedback, which is a highfalutin term, which simply means that if sugar goes up, insulin goes up and puts the glucose back down. Glucose falls, insulin falls, and glucose goes back up. So it's the single key mechanism that tries to fix the glucose at a healthy level to make sure that we're burning fuel correctly.
So I think what I'm understanding is this blood sugar, this glucose is critical. It's sort of the thing that our body most wants to burn, and particularly our brain most wants to burn. But the way our body is built, it's not like there's just this constant pipe of glucose going everywhere. Actually, it's dissolved in our blood, and somehow you've got to keep it at just the right level. Like if it goes too low, I love this idea of my brain malfunctioning. That sounds pretty bad, Rob. But on the other hand, you're saying if it goes too high, it's also a problem. So we've sort of got this system which feels very fragile, the way you describe it, where I've got to keep it at just the right concentration, which is not really like my car, right? Just fill it up with petrol and it's got petrol. They don't have all this complexity.
Indeed, and there's even a little bit more complexity beyond that, because tissues differ in how much they rely on sugar. Brain, as I say, is the most reliant on sugar. But as fasting proceeds, as even heads into starvation, the body can make a series of choices to use alternative fuels as well. And so it does those as insulin levels fall, but always preserving that supply of glucose for the brain in particular. So it's a little bit more complex than your car analogy, because the car can use different types of fuel at different distances of travel to make sure that the key bits are getting the right energy.
It's fascinating. Now, there's been a lot of social media influencers talking about insulin over the last year. And in general, what they've been claiming is that we should be trying to keep our levels of insulin as low as possible. What do you think about that?
When you say it's tremendously important to keep our insulin down, that's just another way of saying it's important to be lean and healthy and eat complex foods rather than simple, highly processed foods. So I feel it's taking a layer of scientific precision and simply saying in a different way stuff that we know to be important. But if you view it in its simplest sense, insulin is essential for life. So to demonize insulin clearly doesn't make any sense. And the best way to minimize your insulin, to make it as low as possible, is to be borderline starved, which is clearly not a way to live life and causes a lot of untold misery. So I think there are strands of truth in that, but I think it's given a degree of weight and a degree of precision which perhaps it doesn't deserve.
Because this is all quite complicated. Could you maybe take us on a journey? Like imagine that I start with that can of soda or a bowl of white rice, and imagine that I'm a healthy person. Could you just talk through what happens and therefore what this insulin is doing, assuming that everything is running as it should?
So if you have a very readily accessible type of carbohydrate, that could be a can of soda, that could be white bread, pizza base, white rice. You will eat that. And because it's processed, it will be digested fairly quickly in the bowel and leads to glucose appearing at the pancreas quickly, which means there's going to be a big demand on the pancreas very shortly after eating to make a lot of insulin very quickly. Now, the alternative, of course, is having some brown rice or some much more complex carbohydrate where you could deliver the same amount of carbohydrate, which is just the precursor of sugar, which takes much longer to absorb and digest, which means the pancreas is never having to perform such a Herculean feat immediately. It's not suddenly having to make a huge spike of insulin. It may make the same amount of insulin, but over a longer period of time. And in those who are insulin resistant or developing metabolic syndrome, that is an easier load for the pancreas to bear than having to do it all at once. So it's not always about the total amount of carbohydrate or sugar. It's about the timing and the rate at which it's released. That's a concept that we call glycemic index.
The pancreas squirts out this insulin, and what does that therefore do to my blood sugar levels?
The pancreas senses the glucose levels going up quickly, and insulin is produced. Insulin will circulate around the whole body. It will tell fat tissue, okay, it's time to take up sugar and turn it into fat. It will tell the liver to stop making its own glucose. It doesn't need to anymore because glucose is coming from the outside. It will tell it to stop burning emergency fuels. So the liver will store up its energy. It will do the same in muscle as well. It will tell muscle that it's okay to turn that glucose into glycogen, the storage form of glucose. And with energy that's left over, the insulin will also say to some other tissues in the body, okay, you can grow a little bit now. These cells can divide. This is good times. Insulin doesn't last very long in the bloodstream at all. That's important to say as well. So it's produced very quickly, but it only lasts for a few minutes. And that's very important because it would be a disaster if insulin hung around for a long time after you'd eaten when it was no longer needed, because then it would suppress blood glucose and cause lack of brain blood supply, and what we call in diabetes a symptom of hypoglycemia. And of course, that happens sometimes spontaneously anyway. We see increasing numbers of patients who are aware, or people in our clinics, who are aware that an hour to 2 hours after food, they're prone to feeling wobbly and sweaty and tremulous. And that's often an overshoot of the blood glucose. That's an overcorrection, so it goes downwards. And it's widely believed, I think correctly, that that's more likely if you challenge your body with unprocessed food, which puts the insulin up very quickly after the meal. So it's another reason to try to smooth things out. So the system is wonderful, but it's not infallible.
So that's how it all works if everything is working well. Let's say I have insulin resistance. I drank my can of Coke, my blood sugar starts to spike, insulin comes out right away, and suddenly all these different parts in my body, like my fat cells and my muscles, are being told, soak up the blood sugar. So what is now going to be different if I have insulin resistance?
So all the same things happen, except this time insulin has a blunted ability to send those signals to fat tissue and muscle and liver. So you need more insulin until you start bringing the blood sugar levels down. And the pancreas is an impressive organ. It responds by making more insulin. So for a long time, people with insulin resistance don't have abnormal blood sugars. They don't have diabetes. They simply have to make a lot more insulin to compensate for the fact that their body responds to it less well. But the immediate concern is that in some people, when they ask their pancreas to work harder, they ask it to make more insulin. That's like asking a muscle to work hard at lifting a weight. Eventually, the pancreas gets tired, isn't able to make so much insulin. And when the insulin that's produced isn't enough to stimulate glucose uptake, that's when the sugar levels rise, and that's diabetes. And so there's been a huge amount of interest in understanding what it is about the way the pancreas responds to insulin resistance, which means that some people get diabetes and some people don't. So it's a powerful system, and the body can compensate for insulin resistance, but every system has its limits. And when it's pushed so far, and this varies between people, eventually it fails to compensate, and that's when blood sugar levels go up.
So could you help me to understand in simple terms the health impact of this?
Diabetes is the name that we use for blood sugar levels above a particular point. And when blood sugar reaches a particular point, that is when the risk of long-term problems with eyes and kidneys and other organs appear. And that's the condition that we call type 2 diabetes. So that clearly is very important. Another question which is less widely understood, I think, is whether or not it matters if your sugar levels are a little bit elevated or they're heading towards diabetes. Sometimes But that pre-diabetes label or that not quite diabetes label can be harmful because it can give people an illusion that all is well. Whereas, in fact, there are other health risks which increase as soon as the blood sugar level is going up. And they're not all to do with blood sugar. Many of them are to do with the other things which are associated with high blood sugars, such as abnormal fat levels in the blood, such as the effect of higher insulin levels to upset the way the ovaries function, for example, or the way tissues grow. So sugar levels above a particular point, diabetes, we're good at understanding that. There are lots of guidelines and trials. But this area, when glucose levels start to go up, or even before glucose levels go up, when insulin is high, is where there is a lot of long-term health risk, which is less widely appreciated.
Let's say I've got this higher level of insulin. What are the different health risks for me, separate from maybe the fact I've then, end up getting type 2 diabetes?
Let's take, for the sake of argument, somebody who doesn't have a high sugar level at all, but they do have a very high insulin level. So in other words, if you have a normal sugar level, but you require a very high insulin level to maintain that, that is pure insulin resistance. As I say, the sugar level is normal, so that's not a problem. But almost always, you will find other abnormalities associated with that. In particular, some of the blood fat abnormalities. So a low HDL cholesterol, which we think of as good cholesterol, high triglycerides, which are the type of fats that are packaged in fat tissue. So those things are real markers of longer-term risk. And there's even more to it than that. Very high levels of insulin, although they're required to store sugar, they have side effects, if you like, because there are some other tissues which can still respond to insulin and even respond too much when insulin levels are high. And one of the major ones of those is the ovaries. It's a very complex organ, the ovary. Each month it goes through a cycle of developing an egg, ovulating an egg, and then resetting and starting again. And there's a very complex choreography of hormones that goes into that. And very high levels of insulin, in short, muck that up and can lead to the ovaries becoming larger. It can lead to them making more male-type hormones, and it can lead to irregular ovulation. And that's the condition called polycystic ovary syndrome. It's now been given a different name to emphasize its metabolic associations. It's polyendocrine metabolic ovarian syndrome. It's not the only reason that happens, but high levels of insulin have a very clear and reversible effect on the ovaries. So actually, often the way our healthcare is organized, people don't put those two things together because problems with irregular menstrual bleeds and extra hair growth and reduced fertility are often looked after by different people who look after blood sugars or fat levels, but they're actually all connected together.
It's really fascinating. So this is starting with the food that we eat and like constantly stressing our body with these sort of spikes of blood sugar because we're eating food that, is broken down into sugar so fast. Our body is doing this fantastic job with the insulin to like push it out more and more and more to deal with what is basically our regular diet in the West. And what you're saying is that actually before you see, type 2 diabetes or those sorts of things, if you are having to have this very high level of insulin day in and day out, then actually it can have a bunch of other health effects. Some of those are things that you can sort of see in your regular blood markers. Like you might have the low HDL cholesterol that's good for you. You might have higher triglycerides. But another area that has a big impact on is your ovaries. But interestingly, you could have these high insulin levels from your diet. So this can be like your white bread and your sodas and just frankly all the ultra-processed foods that we get, actually having this impact on your ovaries without in any way seeing that your blood sugar looks out of control, because actually your insulin is keeping that blood sugar under control, but it's already high and causing you other problems.
That is true. And it's not just the ovaries that are affected. Very high levels of insulin actually also trigger skin growth, which can be very bothersome. It can be very unsightly and it can upset people, but it's not in itself medically harmful. But that can be seen as darkening or browning of the skin around the neck or under the arms or in the groin or in skin creases or even in multiple skin tags around the neck. So again, these are things which are common, which people are well familiar with, but actually they can be signs of underlying insulin resistance. And even more concerningly, in big population studies, as decades go by, it's possible to pick up an increased risk of certain cancers in people who have insulin resistance. Now, I don't want to worry anyone because these are very marginal risks, but nevertheless, they are there. So in the very long term, having a very high level of insulin to keep your blood glucose level the same doesn't come completely without costs. It comes with some sometimes unexpected additional health risks.
And then I think you're saying that eventually your body can't keep this blood sugar under control. And so then on top of that, you still have this high level of insulin and then your blood sugar loses control. What are the health impacts if you are no longer able to keep your blood sugar level in these sort of tight bands that you were describing earlier?
So that's really where what doctors call the microvascular complications of diabetes come in, because high blood glucose is toxic to some tissues in the body, in particular the eyes and the kidneys and the nerves. And that's why anybody who has diabetes will be in a screening program where they have their eyes photographed once every 1 or 2 years, and where people examine their feet and test their urine. So that extra layer of abnormalities, which are particularly caused by high sugar levels, have to be taken into account.
You know, I at least feel like I'm finally starting to understand that, you know, the insulin is separate from just the blood sugar level. It's this sort of hormone mastermind. But with the diets we're eating today, it just feels like it's been made to work so much harder than I imagine our ancestors. I'm sure lots of people listening to this are now going to be worrying that they have it. So I'd like to move on to like how people might be able to tell. How common is insulin resistance today?
Well, of course, that depends how you define insulin resistance. So a simple answer is, around the world, the biggest studies suggest that on average, around a quarter of the population have insulin resistance. And that will vary from population to population, from country to country, from ethnicity to ethnicity, from something like 10% to 50%.
And if you were looking at, say, like the US and the UK, where does it lie in that? You said it could be as high as 50% in some countries, as low as 10% in others.
The US and the UK will be in that sort of 20 to 30% range.
And does insulin resistance develop just because of the type of food that we eat?
No, and this is a very key point. We're all different, and we all differ in the insulin sensitivity we start with, and also how likely we are to get insulin resistance as we put on weight. And actually, we're touching now on one of the big problems in the field. We're dealing with enormous global health problems related to increasing weight, increasing obesity, which is usually measured by body mass index. And governments have to, and health systems have to cope with that. And so a lot of focus is on BMI thresholds, where BMI is good and where BMI is bad. But what we know from very extensive studies now is that some people can carry a huge amount of extra weight. Some people can move into the very obese range and really have not much in the way of insulin resistance or metabolic complications. Whereas some people can still be in the normal weight range, but as they gain weight within that range, they can begin to get those complications. So I think one of the most important things individually is that people stop using such a focus on body mass index itself or size itself, but actually start to focus on whether or not complications are occurring. So I think individualizing your understanding of what your risk is very important.
So I think that obviously begs the question, how do I tell whether I have insulin resistance? And you mentioned a number of symptoms. Will I in general be aware of symptoms if I am in this huge group of people who are living with insulin resistance right now?
So I think you can do this the scientific way or the common sense way. So the scientific way is to do a lot of research into gene variants and measure panels of gene variants and generate risk scores. And all those bits of research are important, and they're coming along. But actually, they don't yet do a much better job than, first of all, looking at your family history and looking to see if you have older relatives who have type 2 diabetes, for example, or perhaps female relatives who've had diabetes during pregnancy. These are all clues that those genes run in the family. Something else to be very aware of is shape as well. So the total amount of fat tissue you have in the body. Where that fat tissue is crucial. And if you are a family which doesn't have diabetes and where there are big people, but they tend to put all the weight on their lower body, the risk is lower. If you have a family where the weight, when it goes on, all tends to go in the middle part of the body with thin legs, then the risk is much higher. So I think having a careful look around the family does tell you something about risk. And risks for our young generation now are higher than they were for older generations because, in general, we live less healthy lifestyles as well. After that, some of the clues that you might get come from those other features, particularly in women. The ovaries, because they are so sensitive to high levels of insulin, almost are like a canary in the coal mine. As I say, there's many reasons that you can get what let's call, for the face of argument, is polycystic ovary syndrome, but insulin resistance is one of the big ones. And so as you put on weight, developing irregular menstrual bleeds, perhaps growing some coarse hair in the male distribution, perhaps having less frequent ovulation or reduced fertility, that can be one of the first clues. Much more difficult in men though, who don't have that early warning symptom, if you like. And as I said before, there are skin changes as well. So if you become aware that you're developing browning and thickening in skin creases in the body, so particularly on the back of the neck or under the arms or under the breasts or in the groin, that can be a clue, strangely, as well. Or even multiple skin tags around the neck or in those flexures as well. These can all be signs that the insulin levels are very high. And so they're increasing the growth of the skin.
So our researchers were looking at what everybody's talking about online about insulin. And a lot of what people are talking about as signs of insulin resistance are things like brain fog, cravings, being tired after eating. Is there any truth to any of this?
I'm sure there is, but it's difficult to know, is the answer. As I've tried to explain, metabolism in the body is incredibly complex. It's not just one thing. It's not insulin doing one thing and either doing it well or doing it badly. It's about fine-tuning the flow of nutrients from one organ to another. And it's not difficult to imagine that you could get some disturbances of that could cause some of those types of symptoms. However, it's also true that often at the ages when people are beginning to develop insulin resistance, there's a lot of other stuff happening in life as well. Often it's midlife, where I am myself, which is a challenging time with caring responsibilities both ways, with new health problems, new health challenges, weight gain, menopause, usually as women go into their 50s. So there are a lot of confounders. I meet many people with very severe insulin resistance who don't have those things. So I do take with a pinch of salt this attempt to put all of those other symptoms into the same bucket and blame it on insulin resistance. I think that's very simplistic and often not true. But I don't discount that some of those types of symptoms can come from fluxes in body sugar.
Do you want to know the most powerful thing that Zoe taught me? Gut health is health. A healthy gut can unlock better sleep, more energy, and it's key to living more healthy years. We're living through a gut health revolution. And Zoe is leading the way. We've used the data from 300,000 gut health tests to create a brand new app and a brand new gut health test. Our app is based on the world's largest microbiome DNA database, developed here at Zoe. And our new app gives you personalized health insights from day one, and then helps you build healthy eating habits that actually stick. Our proprietary AI allows you to snap a photo of a meal and discover immediately exactly what's in it and how it's going to affect your body. It can even identify which processed foods in your fridge might be a high risk for your health and which might be fine. Because the truth is, our current food system is broken, flooded with misinformation, dominated by big food companies that care about their profits and not about your health. You deserve better than this. And with Zoe, you can learn to make smarter food choices and feel healthier in weeks. So how do we know this? Well, we tested Zoe in a randomized control trial that was published in Nature Medicine last year. And compared to a control group, we showed that the people who followed the advice from Zoe's app significantly improved on a whole range of health measures. Add our brand new gut health test, and you can discover how gut clusters work as an ecosystem in your gut to support important functions like healthy fat distribution, your heart health, your blood sugar control. Last year, After just 10 days of antibiotics, my gut was reduced to only 6 of the 50 good bugs. Now, with Zoe's advice, I have 23. And I'm working on improving that every day, every week, month, and year. Because after 8 years and 300,000 microbiome tests, Zoe knows gut health. Are you ready to join the gut health revolution? If so, go to zoe.com.
So I'd love now to talk about, what can you do either to reduce your risk of becoming insulin resistant, or indeed whether it is possible to reverse your insulin resistance or at least improve it. And maybe I could start there. So if someone has developed insulin resistance, is that it? There's nothing else you can do? Or is it possible to reverse it in some way?
Insulin resistance is a product of us interacting with our environments and the things that we do. And so there is a component of this that is fixed, that runs in our genes, in our family. But even people with strong changes in their genes, it still doesn't make it fixed. It actually makes it interact with behaviors more exquisitely. So it's absolutely crucial to understand that no matter what the cause of your insulin resistance is, there is a lot that you can do to improve it by the way you eat, the way you exercise, and the way you lead your life.
If I do improve my insulin resistance, does that mean that it's going to reduce my risk of heart disease and type 2 diabetes and things like this?
Yes. So I'm pausing only because I'm wondering exactly where the large-scale trial evidence is on that compared to what I know from my own experience and my own beliefs. But yes, I would confidently expect that to be the case.
Amazing. So let's start talking about that then. If I'm worried I have insulin resistance, or maybe even a doctor has told me I do, I guess my first question is, can losing weight help? Because you've been talking about weight on a number of occasions.
Weight is absolutely exquisitely important. And as I said, it's not about a BMI number taken from a trial. It's really about the correct body mass index or the correct body weight for you individually. Many of my colleagues and I believe that the roots of a lot of insulin resistance lie in our fat tissue, incredibly unglamorous tissue, barely talked about in medical school when I was training to be a doctor, and yet actually crucial for our sense of well-being and our metabolic health, because if you think about it, it is fat tissue which gives us a lot of our body shape and our sense of well-being because we like what we see in the mirror, but it's also crucial for our health as well. The people who tend to get insulin resistance and tend to get type 2 diabetes are those who have a limit in how healthily they can increase their fat tissue. So as long as you can carry on filling up the cells in the fat tissue, as long as you can carry on making new cells, you will get bigger but stay well. When you reach the limit of the body's ability to do that, then the fat tissue gets overloaded. You're trying to pour more storage into something that won't take it, and it gets damaged, it gets inflamed, and it stops doing its job. And instead of being that fuel tank in the car, or that battery in the car, if you like, which does its job, it sends some of the unhealthy fats elsewhere, to the liver and to other tissues. It creates low-grade inflammation around the body. And so, and that can happen in some people with a normal body mass index, or in some people, it happens very late on. So there's a lot of evidence now to say that whether or not you have a family tendency towards obesity is about the brain and about your energy balance. If you accumulate weight, if you become obese, whether or not you get the metabolic complications is about how good you are at making fat tissue. So the key thing for everybody, I think, is to look at their family history, look at their shape, look at their symptoms and any tests their doctors has told them about, and work out what is healthy for them.
So I had this rather shocking experience early on in the days of Zoe when I participated in our first really large trial. And as part of that, I had a DEXA scan to understand my fat distribution. And I have a lot more body fat than it appeared on the outside. But in particular, it's all what I've now discovered afterwards is called visceral fat. So basically stored, nicely around, my organs in my belly. Is this location of the fat important?
Yeah, this is absolutely crucial. It's not always about how much fat you have, it's whether that fat's working. It's not even about how much fat you have in your whole body, it's about where it is as well. So we know that fat on the thighs and the bottom, if you'll excuse me, is the healthy place to put fat. We know that from many population studies and increasingly studies of people. Whereas fat that goes in the middle of the body, especially inside the belly, that's the visceral fat that is very harmful. Now, I think of visceral fat as being your sort of second level energy reserve. And that increases when the healthy bits of fat in the other parts of your body aren't so good at expanding. So you have to use your second level energy reserves. And visceral fat is very interesting stuff. It's got preferential access to important organs like the liver. So when visceral fat misbehaves or dumps its storage, it dumps it straight into the liver rather than spreading around the rest of the body. And I think as a community, we're only just beginning to understand why all these different bits of fat and different bits of the body are so different.
So, Rob, what about food? If you are insulin resistant, are there particular types of food that you should be trying to limit?
Fats in food are particularly harmful. They also interfere with the way insulin works. As we've said, carbohydrates, sugars, are best taken in healthy, natural forms, which means they get trickled into the system gradually rather than just arriving as a big lump, if you like. White rice or white bread is very processed and will lead to rapid absorption because it's easy to get the sugar out of it. And that poses more of a challenge to the body immediately to make a lot of insulin.
This is one of my most depressing discoveries since I started Zoe, was that bread, particularly like a beautiful smelling, just cooked, white bread, gets turned by my body into sugar in minutes, and therefore is, not really very different from having a can of Coke. But I have taken away from this, not that you should never eat bread, but that if you're eating lots of like bread or white rice as part of a meal, with lots of sort of fat and protein to sort of slow down the absorption, that at least in my case can lead to this really rather extraordinary blood sugar spike in, like 15 minutes.
I mean, one thing I'd say also is I certainly don't want to appear a Puritan, and I'm not a Puritan in my own life. We need to enjoy life and we need to have treats. And a lot of the things which we're talking about are long-term risks that aggregate with time. And so there's no case for living a miserable life in order to avoid metabolic complications. So I think, but I think awareness of these things and trying to avoid habitual, regular consumption of the unhealthy types of food is doubtless very sensible.
So I think we talked about food and we talked about trying to lose weight. Are there any other things that you can do in your lifestyle where there's actual real evidence that it can help?
So I think exercise is clearly important as well. That's the other side of that energy balance equation. But although, of course, it's much more than just being about weight. It's about tuning the tissues, such as muscles, which burn energy and which use up sugars even without requiring insulin. So, and it's also, of course, about sense of well-being. So it depends on life stage, of course, and it depends on personal preference and other factors. But usually a mixture of aerobic exercise and some resistance exercise is the best strategy. So muscles use glucose as one of their favorite fuels. And they are able to use glucose, they're able to use sugar when they're exercising, even without requiring insulin at all. So it's a way to get rid of sugar and to burn it without stressing the insulin side of things at all. And anybody who has insulin-treated diabetes will recognize that. They will know that one of the times when they're at risk of their blood glucose dropping low is when they take insulin and then do lots of exercise, which is a bad thing in that context, but it's a real clue that your muscles are burning sugars even without requiring insulin when you exercise. And that's one of the reasons why long aerobic exercise is such a good thing, because those are the types of muscles which are particularly good at burning glucose.
You mentioned at the same time, however, also doing strength exercise. So why does that matter?
So first of all, it's the strength exercise which increases the size of muscles, and the evidence is somewhat piecemeal. And if I had to absolutely commit to one type of exercise, I think I would pick aerobic exercise because the measured biochemical changes seem to improve most with that. But there are other types of change which improve with resistance exercise. But maybe even more than that, I think. These things aren't a punishment. They're supposed to be enjoyable. And I think variability and mix in diet and in exercise is a good thing, because there's no point, once again, putting too much pressure on yourself to do something that's miserable because you won't sustain it. So I think there's a psychological reason for mixing them up, but I think also there are good physiological reasons to do a bit of both.
And is there like a minimum level of exercise you need to do to get any benefit? And I guess I immediately start to think about a lot of these influencers where it sort of seems like unless you're doing 2 hours in the gym 5 times a week, like frankly, you're not even starting.
No, I mean, I would step right away from any of those types of claims. I think any exercise is good, and what people have the capacity to do is of course, very variable. The most exercise you do, the better it is. But I certainly don't think there is any threshold where it's simply not worthwhile even trying.
What about psychological factors and things like stress? What does the science say today?
This is, if you like, old-fashioned endocrinology, which is the science of hormones. And hormones all interact with each other. And one of the big jobs that hormones do is to respond when we're stressed. However we are stressed, that could be stressed by injury, it could be stressed by illness, it could be stressed by life events, relationships. The body launches a response to those, which includes putting up the body's natural steroids. If it's severe, it can involve putting up growth hormone, putting up adrenaline-like hormones. And all those things are emergency maneuvers to make sure we survive the stress. But they all increase insulin resistance as well. And so any period of sustained stress of whatever type is going to be unhelpful for insulin sensitivity. It's more likely to produce insulin resistance. In fact, some of those hormones, if they're up all the time, they can actually shift our body shapes and make us put fat in the wrong place as well.
I just love the idea that what's going on with us mentally in stress has such direct physical effect, because I feel I was brought up with such a clear idea that your mind and body are completely separate from like these things that the doctor can actually measure in your blood.
Yes, well, I won't comment on the way that you were brought up, but I think that is true. These are intimately connected. The psychology in the brain is just another organ in the body that is exquisitely dependent on metabolism and is exposed to all these fluxes of different hormones.
So the one thing we haven't talked about that people think about a lot in terms of sort of their overall wellness, if you like, is sleep. Does sleep matter?
Yes, sleep matters. Sleep deprivation is, after all, a form of stress, and chronic lack of sleep will have all those effects that I talked about. It will increase stress hormones and in turn increase insulin resistance. But there's a nuance as well. And we've lived on this planet as a species for a long time. And we have evolved to try to predict the ways of this planet as well as we can. And one of the ways we've evolved is to develop an exquisite daily pattern of our hormones, which predicts when the sun goes up and when the sun goes down so that we're ready for the day. And we now live much more disorganized lives with electric lighting, shift work. And if we are trying to live our lives, including eating food and doing exercise, which is not in the normal pattern in which we've evolved over millions of years, that in itself is a stress and leads to unhealthy metabolism, including insulin resistance and weight gain as well. So it's both about the total amount of sleep and it's about the regularity and pattern of sleep as well.
So not having a sort of really regular cycle of sleep time and wake time is something that can actually disrupt your ability to manage this whole insulin and blood sugar interaction?
Yeah, exactly. And it's something which is prompting a lot of thought about people who do shift work or people who move time zones regularly as well. There are particular challenges for those people too. I think that is unhelpful. I think that is an extra layer of challenge on top of other things such as the way you're made, your genetics and your natural tendencies. So I wouldn't overestimate it. It's important that people do those jobs, but I think awareness about that and mitigating that where possible to minimize the disruption of sleep-wake cycles is important.
If someone's been listening to this podcast and now for the first time they are worrying about their insulin resistance, if you could only give them one piece of advice that maybe they could start on today, what would you tell them?
don't worry about the unknown because it comes with a complicated name. But I would say have an awareness from all the things that you know, from your family history and from anything doctors have told you, where your personal risk lies. And if you believe that you are at particular risk, then set your own targets and don't pay too much attention to the population average targets which doctors set.
Rob, thank you so much. I'm going to have a go at trying to summarize our conversation. I hope you'll correct me if I get anything wrong. The first thing I'm struck by is that about a quarter of the population in the US or the UK have insulin resistance. So that's a huge number of people. And this is a big deal because that's a serious risk, not just for diabetes, but for many other diseases. On the other hand, I think what's really positive is you immediately said, well, yes, insulin resistance can be reversed. So it's not like this one-way track, which I think many things feel like, as we get older. You said, I thought this is really wonderful. Insulin is obviously the most important and best hormone because basically it is managing all the energy in our body. And therefore, if it wasn't managing that just right, we would die almost instantly. And that's because it's managing this level of blood sugar in our body. It's saying, oh, the blood sugar is too high, right? We're going to push that energy into your fat cells and they're going to balloon. Oh, we really got to pay attention. That blood sugar level is low. And we have to get blood sugar into your body because otherwise your brain is going to die in just a few minutes. And so there's this incredibly sensitive balance going on all the time inside us. And you said our body is amazing and our pancreas can get stronger and stronger and pump out more and more insulin. But actually, as it does this, eventually the insulin doesn't work as well. And so that is really insulin resistance. It's that we're creating far more insulin than you should do in order to have the same effect. And eventually you can't make any more insulin and you sort of spin out of control into something like diabetes. I had thought, as long as your blood sugar is under control, everything is fine. But actually that's not true. As your research and others has shown, once you're starting to produce these really high levels of insulin, even if your blood sugar level is still under control, you can have some serious problems. And so it's an indicator already of something that is going wrong. And there are different ways in which this can happen. You said if you're a woman pre-menopause, often actually you'll see this through your ovaries. And it's sort of like, I think it's a canary in the coal mine. And so you might have PCOS, and you might see that through menstrual bleeds or hair growth or impact on ovulation. That's sort of like a warning of what's going on with this insulin, and you're seeing the direct impact. But you might also see it in your blood. So you might have lower levels of the good HDL cholesterol. That's already showing you that you've got this long-term health risk. And then I think a few other specific things you said. So if you're getting, I think you said darkening of skin around your neck or skin tags, that could be a real sign that your insulin is high. If you reach the point when your blood sugar is then not under control, you get all these other added risks that are to do with diabetes around your eyes and your kidneys and your nerves. But the good news is there's stuff that you can do. So the first thing is weight is a big factor, and particularly weight in these bad places like the visceral fat, that's really bad. Whereas actually if your weight is on your thigh and your bottom, it can be healthy. But if you've got a lot of weight, that's a real risk factor here and you'd like to try and reduce it. Food is clearly a central issue. We were talking about rice and white bread and sugar in your drinks. This is a big problem because it leads to this big spike of blood sugar very fast. And if you can just move to something where you get the same level of carbs more slowly, then your body is just going to cope with that so much more easily. But it isn't only about food. Sleep and exercise are important as well. And then particularly on exercise, your muscles do something very special with glucose. They actually can pull it out of your bloodstream without using insulin. And so that's actually really great if you've got a problem. And so you said the best thing is sort of aerobic because you're going to use this for this extended period of time. But there does seem to be evidence that the resistance training, maybe because it makes the muscles bigger, is also good. So in general, a mix is good. But critically, whatever you're doing with exercise, if you're doing a bit more, it's going to help. You don't have to sort of be 2 hours in the gym in order to make any difference.
Yes, you've summarized that very eloquently. I think perhaps my instinct is to finish on a positive note as well. As you pointed out, most of our evolution as a species has happened in times when we were grubbing around for tubers, as you put it, or every so often killing an animal. And you might now say, well, why is it that up to 25% of the population could have this harmful state called insulin resistance? And I think there's reasonable ideas and some evidence that maybe those same people would have flourished particularly well in those times. Perhaps after a period of famine, they would have been able to turn on fertility faster when the good times rolled. So those people who are at the moment unlucky to be the people with a tendency towards insulin resistance may actually have been the survivors in the tough times of us as a species. So it's all dependent on context.
If you enjoyed today's episode with Professor Rob Semple on insulin resistance, I know you'll love watching this conversation with Professor Naveed Sattar from the University of Glasgow. In it, he explains how to prevent, treat, and potentially reverse type 2 diabetes.